In this demonstration, I will give an overview of various settings that you can use at your disposal to get peak optimal performance when using SimCenter Nastran. There are many different settings that we can adjust depending on your problem, but in this video, I'm going to touch on 4 key settings that can really impact the time it takes to solve a model. Those are memory, scratch memory, SMP, and this is otherwise known as shared memory parallel, and finally, our element iterative solver. Let's take note that the first 3 are solver parameters, while the last is a solver type. In this example, we have a 5 million node model, and we're going to be performing a Solution 101 linear statics. Here we can go into our solver parameters and make adjustments. First, let's discuss memory. By default, Nastran is set up to use 45% of your computer's physical memory. Depending on how much memory your computer has and how much open core you want to allocate for a specific job, you can specify memory as a percentage or a value. Allocation should be no more than 80% of your physical memory. And this is to avoid overallocation for better performance. You can check your memory by going into your task manager and seeing how much memory your computer has. Next, we can specify if we want scratch. When set to yes, this deletes the database files at the end of every run. We can also adjust this to no. This will store the files and can be used to restart your analysis. We also have the mini option. This specifies a reduced size database that can only be used for data recovery restarts. When specifying a scratch directory, we want to do so at a location that has sufficient space. We can also greatly enhance our performance by specifying a number of processors we want to use to partition the matrix data in the vector operations. This can have a large impact on dramatically reducing the amount of solve time it takes for the model. In one example, we can see a clear drop in solve time by specifying up to 12 processors. An ideal range is anywhere between 8 and 12 processors. We can also specify other parameters, such as our scratch memory, under the additional keyword section. By default, scratch memory is set to 20% of the open core memory. Users can adjust this to reserve more or less for scratch, which can help when a model goes out of core and typically tops out at 80%. It's been shown that using the default is ideal for most models. However, for larger models with millions of nodes, more memory is needed to keep your model in core. When your model goes out of core, it writes to the specified disk of your scratch folder. You can adjust the scratch memory on a trial and error basis to try to keep your model in core. This will dramatically reduce computation time. If we want to change our scratch memory, we can specify smem or smemory and have that equal to some percentage of our memory. In one example, the scratch memory was adjusted from the default of 20% all the way out to 80%. The biggest reduction came at around 60%. Anything past the 60% mark didn't show any further benefit. Again, this may depend on your computational resources and model size. Be sure to check out part 2, where I get into solving an example problem using the solver parameters. We'll also discuss the iterative solver, and finally, we'll talk about the FO4 and log file and how that can be used to better understand SimCenter Nastran performance.